Teepen here. If you've ever been out to the snow or a frozen lake, you will have realized that walking on that can get very slippery. You could even get hurt by falling down and slipping. Well, scientists have wondered for a very long time, why is ice so slippery? I mean, when I walk out on other solids like concrete or grass, I don't slide around, but why do I slide around when I step on ice? Before I get into that, let me tell you something about how solids work. Most solids have a crystalline structure. What that means is that the atoms come together in what we call a ball and stick model. They attach together by these sticks and they form a big square. When you put a bunch of these squares together, you get a cube and eventually you get a solid. This is exactly how ice works. Water freezes, comes together, and it forms ice. Now in physics, one thing we learned was that as accurate as that model is, it's not perfect. The atoms, they're always moving. Atoms don't like to stay still. They vibrate around. So the way physicists have remodeled this is by taking two atoms and instead of joining them together by a stick, they'll put a spring. That way, when they vibrate around, the spring keeps them in place but allows them to move. This is known as the ball and spring model. And while this model may not be perfect, it's a pretty good model to describe what happens. Now when you take this ball and spring model and start to heat it up, the atoms move around a lot more. They begin to move around so much that the springs start to break. When that happens, the atoms can freely flow over each other and you get a liquid. This is exactly how solids turn into liquids through the melting process. However, heating it up is not the only way to get atoms to vibrate more. When you put the atoms under pressure, that makes them want to move around even more. So, at a temperature lower than the melting point, you can get water to melt just by adding pressure. Now, one thing chemists have discovered is that you can plot this. If you increase temperature, it'll melt, or if you increase pressure, it'll melt. So there must be a direct line that if you cross any pressure or temperature, then the water will melt. And this is exactly what chemists have done. They've come up with something called a phase diagram. A diagram where water or other substances changes phase to be able to come up with when water or other substances are going to melt. So how does that apply to ice? Well, you see, what causes you to slip is that there is a thin film of water that comes over the surface of the ice. The water fills in any gaps and makes the ice so smooth that you can't get any traction and you slip. Well, here's the issue, is how does that water form? As we described earlier with the ball and spring model, when the atoms vibrate so much, they break the springs and the ice turns into water. Well, that's kind of what's happening here. First things first, when you have a frozen lake per se, then all of the atoms are connected by springs. Well, not all of them. The very surface only has springs on 3 of the 4 sides. Because of this, the atoms on the surface aren't as strong, and a lower vibration will cause the springs to break. So that's the first key, is unstable atoms due to the lack of springs. Here's the second key. When you stand on ice, you have a certain amount of weight. You exert that weight by standing on your feet. Everyone knows that, right? Well, here's the thing though, is that because your feet are much smaller than the mass of your body, you exert a high amount of pressure on the ice, somewhere on the order of about 20 atmospheres. As we mentioned before, when you increase pressure, this causes the atoms to vibrate more. However though, if you run the numbers on that, 20 atmospheres is not nearly enough unless the ice is very close to its melting temperature already. As a result, there's got to be something else at play here. We have unstable atoms, you exerting a pressure on the ice, but that's that third thing. Well, when you step on ice, you're moving your foot. And when you move your foot, you're exerting friction. Now, as you guys know, when you rub your hand on a table or something, it starts to heat up. The same thing is happening when you rub your foot on the ice. You're exerting friction and you are heating the ice. So when you heat the ice, add pressure to unstable atoms, the springs break. And that's exactly what's happening, is that you are breaking the springs, causing a very thin film of water to exist between your foot and the ice. That water fills in all the roughness that the ice provided, causing you to lose traction and slip. And with that, my name is Teepen, and feel free to check me out on social media or subscribe to my channel. Peace out.